100, then it will show you 100 records, right? So it's showing you 100 records, right? Okay, fine. So this is all we understand so far. Now, before I move forward, I just want to give you a high level idea that I feel there are three parts to Spark. One is, right, one is understanding the internals and architecture of Spark, right? We are in this phase currently, right? We understood the architecture, we will discuss more, but today we are going to focus on internals of Spark, right? We will see Spark UI and all of that, right? Next thing will be data transformation, how you will transform data, right? Most of you would have transformed data using SQL, right? But we will learn data frame API. What is the syntax, how we group data, how we join data, how we filter data, window functions, and all of that. And third thing is performance, right? How do we uh, improve the performance of my jobs, of my Spark job, right? Performance. Okay, so this is how we will follow. So today we will focus on internals, right? If if it is over today, then from tomorrow we will start the transformation, how to transform data, all of those things, and then we will pick up the performance things. And in the end, we will obviously have a project, right? So we are focusing on this, and this is one of the most important part of this full boot camp, right? Whatever we are learning today. Great. So let's continue, right? So we said that we are saying Spark that infer the schema. So you read the data from my CSV file and infer it. And it has inferred. And if you see the schema, you will be able to see the schema, print schema by doing print schema. Right? So it is telling me that these are the columns and data types. So everything it has inferred automatically, integer, double, date, string, integer. So it is all fine. But at the same time, this is not the best way of doing things, right? This is not recommended way to let Spark infer schema. You should enforce the schema. You should tell Spark that this is my schema. Please, you don't infer because it can infer wrong. Also, performance wise, also unnecessarily, it will be scanning the data, right? So we don't want Spark to infer the schema, not a great way. We will pass the schema. So how we will pass the schema? So let's create a schema variable. So if you want to see all the columns, just the columns, you can just say df orders dot columns. So it will give you the list of columns, right? So I'll just copy this. Great. What I will do, let me create one more cell, right? And I will say, let's say orders underscore schema, right? Equal to, now here I'll just remove this everything. I'll take everything in one line. Okay. Now here I'll say that I'm defining my schema, right? There are two ways of defining a schema. This is one way, and there's another way we will learn later. So I will say that my order ID is an integer type. So I will say order ID int, right? This is my integer type. Maybe I can print a schema here so that we use the same schema. Okay, so this is int. You can give int or integer, both works. Again, customer IDs, we don't need this. We just give a string where we have comma separated all the columns and their data types. Customer ID int, right? Product ID is also int. Now, price is double or float. You can give anything. I think float also works. Then you have order date, which is date. Right? Then you have order status, which is string. Right? Then you have a state, which is again a string. String, and then quantity. Quantity is integer, right? So I'm giving just one string I have created. In that I have column name and data type, comma, column name, data type, column name, data type, and this is how I will give it, right? Now, what I will do, right? Let me copy this. I will say dforders.spark.read.format dot option header is true, which is fine. I have header in my file. Then I will not use infer schema equal to true. I will say dot schema and I will pass the my schema. So I will say dot schema and this is my schema. So now I'm not asking Spark to infer the schema. I'm passing the schema that I know the schema, use this schema, right? Don't infer it, right? And then if it doesn't have to infer, then this doesn't make any sense, right? Sampling ratio. So we will remove it. And then we will say load, right? So now instead of infer schema and sampling ratio, I'm upfront telling that this is my schema and read it, right? And let me run this now. Now, if you see, it is giving me the schema, and if you see, it ran so fast, right? Because this time it was, so if I run this, you just see, it is taking some time because it has to read the data, get the data types and show it. And we are just reading 10%, right? Here, if you see nothing, it is immediately giving me it, right? There is no processing. Spark is not doing any work in the background. Why? Because I'm passing the schema, right? So it doesn't have to go through the data. So I hope you understand this. Great. So we will see another way of giving the schema later. But for now, you understand this is the way you can give. Just column name, data type, column name, data type, and you pass it here. Okay. Now we have been talking about this from a long time that how many partitions will be created, right? How many partitions will be created? So we are saying this is a distributed system, right? When we create a RDD, right? It is this data frame is basically built on top of RDD, right? So RDD is a resilient distributed data set, and this is also distributed. So when I create this data set, it would have created multiple partitions, and those partitions will be processed parallelly. Now we will understand how many partitions will we create. So the size of my file is 1 GB, and I will show you the exact size also. It is not exact 1 GB. I think it is more than 1 GB. So let me copy this, and this is my file, right? And let me check info. So this is around 1.13 GB, right? Let me copy this. This is around 1.13 GB file. This file is, I'll just note down here. Okay. Now in Spark, there are a lot of configuration, right? Spark level configuration. Based on that, few things will happen, right? You can change those configuration, but there are some default value. So for example, right, there is a configuration. Let me show you quickly. Um, yeah. So let me see this. So this is a configuration, right, which is there by default. You can change it, but it is not recommended to change it, right? You should not change it until and unless you have a very strong reason, right? So this is Spark from Spark configuration. I want value of this configuration, right? So let me just run this. So this is this many bytes, right? So if I convert it to MB, it will be 128 MB, right? So let me show you. So I'll say this divided by 1024 into 1024, right? So this will give me size in bytes. Uh, Something is wrong. I didn't copy it properly, I think. Let me just remove it. Okay. Yeah, this one is missing. Okay. 134217728. Yeah, now it is fine. Okay. So if you see, it is giving me 128 MB, right? So it is saying spark.sql.files.max partition bytes. So it is saying the size of my partition should be maximum 128 MB, right? It is saying that size of my partition, if you are creating multiple partition, right? I have a data set of 1 GB and I am saying I will create multiple partitions and those partitions will run parallelly, right? This is how distributed computing will work. So this property is telling that size of your uh, partition should be 128 MB. Now you see the size of my file is 1.13 GB, right? So how many partitions will be created, right? Can you do some calculation? So size is 1.13 GB divided by 128 MB, right? So what will be the size? It will be something, I think 4 point something, right? So let me try this. So what I will do, so this is GB, right? So let's convert it into MB, 1024, right? And then divided by 128. Let's see what will come. Okay, it is coming 9.04, right? So it is around 9.04. Okay, it is not exactly 1.13. I think it is around 1.12. You can check exactly, right? But it will be around 9. 9 partitions will come around, right? Right? It will be around 9 partitions. Great. Now let's see how many partitions are created when I read this data. So how I will check number of partitions? So I will say, um, let me show it here itself. So I'll say this data frame dot rdd dot get num partitions. And I'll just check how many partitions are there. So it is telling me 9 partitions, right? Which means it is creating a partitions of 128 MB and it is creating 9 partitions, right? Now let's see this in action, right? Let's see in Spark UI how this looks like. How these 9 partitions are getting processed in parallel, right? So we want to see this. For that, I'll write some code, right? So let me remove this for now. Okay. Maybe I will put a filter. I'm not telling you currently how to do transformations, but just a simple filter I'm putting, right? So let's say df underscore orders dot show. Just wait for a moment. I'll explain you everything. So I'll say df orders filtered equal to df underscore orders dot filter. It's okay if you don't know this syntax. I'm just filtering some data and want to show you something, right? So I'll say, let's say states equal to let's say Delhi, right? And then I will say df orders filtered dot show. Okay. So this is giving me Delhi data, right? It's okay if you don't understand that syntax. We will talk about it, but basically we are just filtering data where I'm saying state equal to Delhi. Okay. Now I want to see this, that how these 9 partitions are getting processed on Spark UI. But there is one problem. The problem is when I do show, it is showing me only 20 records. So it is not processing all 9 partitions. It will just process one partition and give me data. Right? So I will not see the full plan on Spark UI. Right? To see the full plan on Spark UI, either I should do collect because collect will give all the data. But the problem is it is huge data. If I do collect, my driver will go out of memory. We have seen earlier as well, right? So this will stop. Instead of that, I can do write, right? Write will also do, write will also process full data. So I will say dot write dot mode override, right? Override, right? Dot format CSV because I want to see full processing, how these 9 partitions are getting processed. And when you do pipeline also, show is just to understand the data that your transformations are right or not. Ultimately, when your pipeline is running, it will be writing somewhere, it will be processing all the data, right? So if I want to see the full plan, I will do something like this. So what it will do, it will write full data and my full processing will happen for all the 9 partitions. Now there is a concept of dry run as well. In that, you just say this, save it, and instead of CSV, you say no operations basically. So what it will do, it will process your all the partitions, all the data. It is just that it will not write, right? So this is kind of dry run. So every time you are designing a job, you want to do the dry run without writing data because writing data again will take time, right? So you will say format no op mode override. So it will run your full job, right? But it will not write data. But you will see the full plan on Spark UI. Okay. So now what I'm doing, I'm saying df orders filtered. I filtered data and then I'm writing this so that full data will be processed and I will run this. So it is running and something is done, right? I'll go to Spark UI. Spark UI is here, right? Let me refresh it. Okay. So this is my Spark UI, which is on 4040, localhost 4040, right? And this is the latest job I just ran, right? These are the old jobs it is showing, but this is the job it just ran, 349. So let me open it. Okay, so it is showing me something, right? So it is showing me one job basically. So this program I ran, right? It has created one job. If you see, or let me do one thing. I'll stop the Spark session and show you again so that you see there is only one job. So what I will do, I will say Spark dot stop. Okay. And then I'll just create the session again. Okay. And if I go to the Spark UI jobs, nothing is there, right? I just want to show you that how many jobs it will create. Okay. So I'm going to run this code again. There is no job currently. You see, it is all empty, right? And let me run this. So this is done. Let's go back, refresh it. And you see there is one job, right? So Spark creates one job for every action, right? So we understand there are some transformation and there are some actions, right? Actions are collect, show, write, and there are a few more, right? We'll see. But these are the actions basically, right? So for every action, so how many actions are there in this code? There is only one action, right? Right? These are all transformations, not actions, right? This is a transformation, this is a transformation, this is the action. Action means when I want some data, right? Until unless I don't want data, Spark will not create any job, it will not do any work, right? We discussed that it will just create a DAG, right? It will keep creating the plan till here, right? But it will not execute anything, it will not process any data. Only when you apply a action, right? This is a lazy evaluation. Right? We'll see more application of it. But basically, at this point, you should understand that for each action, one job will be created, right? So there is one action in this code. There is only one action, right? There is no other action. So write is an action and it has created one job. Right? So this is my job. Now we will go inside job and see what is happening. Okay. So this is my DAG as I was telling, right? It will create a DAG, right? So this is a scan CSV and then we are writing data, right? We'll understand later what is whole stage code gen, but basically we are scanning CSV and doing some filtering and writing the data. Now, if you see, it will create multiple stages. In our code, there is one stage, right? We will see when it will create multiple stages. But at this point, you understand there is one job and there is one stage. Right? We will see when it will create multiple stages in which scenario. but there is only one stage, right? And this is the stage you can see here, right? Let me move this. Okay, there is one stage, right? Stage ID 0, and we can click here and see further. Okay, so let's go down and click on this. Okay, great. So now you see few things here. Let's understand one by one. So if you see, there are 9 tasks in this job. So the smallest unit of work in Spark is task, right? Smallest unit of work is task, and number of tasks equal to number of partitions. So how many tasks will be created will be based on how big is the file and how many partitions are there. So in our case, we saw that there are 9 partitions. So it has created 9 tasks, and each task will process one partition, right? So there are 9 tasks. Each task will process one partition, right? So this is how it works. So we have job, right? This is how it is. So we have job. Then within job, we have stage, right? It can create multiple stage, but for now you understand we have one stage. We will see when it creates multiple stage. Then within stage, right? So job is for every action, right? Every action creates a job, right? By default, there will be one stage, but there can be many. We will see later. And then within each stage, we will have tasks. And task will be equal to number of partitions. Okay. So if I go back here, it is saying that there are 9 tasks from 0 to 8. Right? Within each stage, we will have number of tasks, and we have 9 tasks here. And if you see, why 9 tasks? Because we have 9 partitions. So, and each of these tasks is processing 128 MB of data. So this is one partition, right? Second partition, third partition, and for each partition, we have one task. The last partition has less data because if you multiply 128 by 10, so whatever is remaining, right? So it will, we have 8 full partition, and whatever data is left, for that we have one partition. So 8 partitions are of equal size and one is small. So if you add it up, it will be 1.13 GB basically. If you add it up, it will be 1.13 GB. It is also showing you that how many number of records are there in each partition. Right? So you can see everything on Spark UI, right? You don't understand everything for now, but at least you understand that based on the size 128 MB, right? We have 9 tasks, sorry, 9 partition, and for each partition we have task, and these tasks will run in parallel. Okay. Now I'm using a very strong word here that they will run in parallel. Will all of these tasks run in parallel, do you think? There are 9 tasks, right? Do you think all 9 will run in parallel? No. It depends on number of cores we have. So my system has 4 cores, right? So let me show you the um, master UI. So local host 7077, right? My master is, no, not 7077.
80.
Okay, 8080, yeah. Okay, so if you remember, we have 2 workers, each has two cores. So we have total 4 cores, right? If you remember, when we created the Docker file, to each worker we gave 2 cores, and you can see it, 2 cores, 2 cores. So there are total 4 cores, which means I can run 4 tasks in parallel. I cannot run all 9 tasks in parallel. Maximum I can run 4 tasks in parallel. So each core can process one task at a time, right? So how it will happen, right? We have 9 tasks, right? 9 partition, 9 tasks, but I have only 4 cores. So what will happen? these four cores, let's say core 1, core 2, core 3, core 4. These are my cores, right? And I have 9 partitions, let's say P1, P2, or task, let's say task, right? Because ultimately it is tasks are running for each partition, right? Now what will happen? It will process task T1, this will process T2, this will process T3, and this will process T4. So these 4 tasks will run in parallel. When I say task, it is each partition. Now you should be able to understand. Once these tasks are completed, let's say my T1 is completed, then to this core 1, right? It has completed T1, so I will assign T5, right? As soon as T2 is completed, I will assign T6. As soon as T3 is completed, I will assign T7, right? And as soon as T4 is completed, I will assign T8. Now let's say T6 is completed. Others are still in progress. So the last partition or last task, I will assign it to this T9. And this is how in 3 cycle, this will be completed. 2 will be full cycle. All 4 cores are used. In last one, only 1 core will be used. Right? So this is how I will process 9 tasks. And we can see this in the UI. So I'll go back to UI. And here you can see this, right? So if you see, we have 2 executor, right? Each executor has two codes, right? So if you see, we have 2 executor ID 0 and 1, right? One of them has executed 4 tasks and another one has executed 5 tasks, right? And here executor ID is also there, that which executor has executed which task. So task 0 is executed by executor ID 1. So we have 2 executor as we see, right? Each of this has 2 codes, but this is executing 4 tasks and this is executing 5 tasks. Now if you see here, 4 tasks started in parallel. So to executor 0, right? This is the executor. So these are 2 tasks are working. So you see task 1 and task 3 is assigned to executor 0 and task 0 and task 2 is assigned to executor 1. As soon as this task is over, 2 more tasks are assigned to this. Similarly, as soon as these tasks are over, we are assigning one more task, right? And in the last, there is one more task which is getting assigned here, right? So there are total 9 tasks which are getting executed, right? Now in this task, there are different things that we will learn later, that there is some task deceleration time, execution compute time that we will discuss. That's fine. For now, you have to understand how it is working, right? Let me explain you again on the board so that it is absolutely clear to you. It should be very clear to you. If not, please ask me again. Okay. So let me move it a bit. Okay. So I have a file, right? This is my 1.1 GB file, something around. Okay. Now, as per the rule, right? The maximum partition size can be 128 MB, and as per that rule, I have 9 partitions. Right? So as soon as I move this, I read this file in Spark. In Spark, the data frame or backend, it will be RDD will be created, which will have 9 partitions. Right? Now I have 2 executors. Right? So executor 1, and then I have executor 2. Right? Each has 2 cores. Right? You can give more cores as well. 2 cores. Right? And this also has 2 cores. Right? Now, what Spark will do, right? It will check, okay, there are 9 partitions. So this is a driver's work, right? So driver will see, okay, there will be 9 partitions, and then it will assign the task to these 2 executor, right? So for what it will do, so for each partition, one task will be created. So it will assign 2 tasks to this because only 2 tasks can run in parallel, right? Because there are 2 cores. And this will also have 2 tasks first. Right? As soon as these 2 tasks are over, it will assign 2 more tasks. And again, as soon as these two tasks are over, here also two tasks, right? So overall, 8 tasks are done. Now, wherever executor is free, it will assign one more task. So maybe executor one will have one more task. It will take less time relatively because it has smaller data, less than 128 MB. You can even see this. See, this is taking more time, right? And this is taking less time, right? If you see here, this is taking 0.6 seconds. This is the small partition which has only 53 MB. All of these taking 2 to 3 seconds based on the sources. Basically, I did some kind of parallelism. In the case, let's say one task is taking 2 seconds, right? Let's say one task is taking 2 seconds. So if everything was on one system, right? So how much time it will take? 2 into 9, 18 seconds it will take, right? If there was only one core, let's say we have only one core, there is no parallelism. So it will take 18 seconds. Now, how much time it is taking? Now we are executing 4 tasks in parallel, right? So first four tasks done in 2 seconds, right? Next 4 tasks also done in 2 seconds because 4 tasks we are running in parallel. Imagine if we have a big cluster of, let's say, 100 cores. So 100 tasks can run in parallel, right? Then one more task, it will also take, let's say, 2 seconds. So we did in 6 seconds instead of 18 seconds. Maybe it will take 1 second. It is a small one, but based on size, it will take time. So we did everything in 5 seconds instead of 18 seconds. How? Because of this parallelism, because of this property of RDD, that this is distributed across worker nodes, right? Worker nodes or executor. For now, you understand them as same, right? So this is how parallelism is working. Great. Awesome. So what all we understand here? We understand this task, right? We understand how much data they are processing each task and how much time they are taking. There are other things we will understand one by one, right? And also we are seeing that which executor. So we have two executor. So it is just showing which executor is executing which task. We also see aggregated matrix by executor, that executor 0, total time it took 9 seconds, executed 4 tasks, there is no failed task, and input size was 512 MB, right? So it executed 4 tasks of 128 MB. So it is 512 MB. And there is executor 1, right? We have two machines, two executors, right? This is also taking 9 seconds and it executed 5 total tasks. And this is the total data it processed, 565 MB. So if you combine them, it will be the size of our file, 1 GB file. Okay, so we are seeing everything purely. Another thing it is showing me is some statics, that what is the minimum size of any task. So there are 9 completed tasks, right? So minimum time taking is 0.6. So this task took the minimum time 0.6. Maximum time, how much it took? 3 seconds, right? So maximum time taken by any task is 3 seconds, right? And it is GC, we will see later what this is. Garbage collection time we don't understand at this point. Later at some point we will understand what is GC time. But this is again showing me the size, that minimum this size and maximum this size, and this is again medium, 25th percentile, 75th percentile. And here's the timeline, event timeline, that for each executor which task was assigned. Once the task was over, new set of tasks was assigned until unless everything is over, right? And this is my DAC basically. So I'm scanning the CSV and I'm doing some filters, right? So if you see, it is all showing in the RDD because ultimately it is under the hood RDDs. So we are scanning it and doing all the. So this is how you see the UI. Now in UI, there is one more thing, right? That you see the logical plan. So this is the job, right? Job ID 0. And here you go here, SQL data frame. So this will be available only for data frame API and SQL. If you are running your jobs directly on RDD, you are doing transformation, you will not see this. So if I click here it shows me the plan. So it is saying that these many rows were there in the CSV file, right? And this is the filter we applied, right? And this is the override by expression, right? We'll talk about this more later. But basically, you can see the SQL engine's logical plan here and everything else here. So you will state jobs, and this is your DAG, and you have a stage here, and you have all the tasks. Great. So I hope you understand this. Now, before I take any doubts, I just want to show you one more thing, right? So let's say now you answer me this, right? So what I will do, I will just take this code. Let me take this code. Okay, and maybe I'll create a new cell. Okay. So now instead of reading this 1 GB file, right, I will read another file which is, let's say, 300 MB, right? It is a similar file. Let me show you. Open with text editor. Mm, it has the, it doesn't have the header. We want, okay, header is not there, it is fine. We will say header is false and then we will read it, right? So let's go back and we will say, I want to read 300 MB file. And I'm giving the schema and header is false. I don't have header in this file, right? Let me just see if everything is fine or not. So df orders dot show, just to see everything is fine or not. Okay, so this is fine, right? Because we said header is false. So it is not. So if I say header is true, what will happen, right? Let's see. So if we are saying header is true, the first line is gone, right? It is not taking first line. See order ID 2. So we will say false. Okay, great. So now you should tell me, let me show you the exact size of the file. So if I just say info, so it is around 335 MB. Now you tell me how many partitions will be created. Tell me in the comments, in the chat. Please put it in the chat. 3, 3. Okay. Everyone is saying 3. Some Satish said 4. Okay. So most of you understand that it will be 3, right? And your understanding is completely right. But there is one problem. So we are saying it is 335. So if I just say this, let me comment this. And if I say 335 divided by 128, if I run this, this will be 2.6, right? So as per our understanding, it should create two full partitions of 128 MB and one will be less. So it will be around 35 plus 34, 69 MB around, right? So there should be three partitions. Okay, great. So if we create three partitions, right? How many tasks will be created? Three tasks, right? But don't you think we can run four tasks in parallel? We have four core, isn't it? If we have three tasks, then only three cores will be occupied. Only three cores will be used and one core will be idle. This is not a good thing, right? We have a cluster and we have all these resources, right? We should use all the resources. Isn't it bad? Do you guys think it is bad? If we have only three tasks, then three cores will be used. They will run three tasks in parallel, but we will have wasting one core. It is just sitting idle, right? So Spark is smart. It will say that if we have four cores, right, then I will create minimum four tasks, right? I will create four tasks. The size can be less than 128 MB. The size of partitions can be less than 128 MB, right? So that all four cores are used. So let me show you, right? So let me comment this and I'll show you then how do you calculate the number of partitions. So I'll say df orders dot rdd dot get num partitions, right? And you see it is showing 4, not 3, because it knows that I have 4 cores, right? It knows I have 4 cores, so it will create little smaller partition, but now it will run four partitions in parallel. It will run four tasks in parallel. Each of these partitions will be around 85 MB, right? Will process 85 MB, 85 MB of data. This 128 MB is the max limit, right? But Spark can always create partition less than that, right? So it will create 85 MB, four partitions, and these four tasks will run in parallel, and we will have more parallelism basically. The idea is to have more parallelism, right? So let me show you on the UI as well. So I'll just copy this part, right? Filter is not required. I can directly write, then also I will be able to see, right? So I will say df orders dot write dot mode and all of this, and let me remove this, right? And let's run this. So it is done. Let's go back here. Sorry, here, jobs, and this is the job we just created, right? And scan CSV, we are not filtering it anything, right? So if you see, there are four tasks now, right? And all of them are, see, 81 MB, 81 MB, 81 MB, 76 MB, right? So they are uh, processing this much data, right? And these are the number of records. So each executor is executing two tasks, right? So this is a some kind of performance improvement. Spark is done automatically for you, right? So how you will, so let's create a formula that how you will calculate number of partitions in a data set. So it will be max of, right, size of your file divided by 128, comma, number of cores. Whatever is the maximum will be number of partitions. Number of partitions equal to max of size of your file 128 MB and number of cores. So initially, let's see one by one. So let's see for 1.1 GB file, right? For 1 GB file, 1.1 GB file, 1.1 divided by 128 was 9, comma, number of cores 4, and we will take max of it, which means there will be 9 partitions, right? Let's see the second case where we have 320 MB around of file, right? Now size of your file divided by 128 will be how much? 3 point some or 2 point something, 2.6. Let's say 3, right? And then your cores is 4. So how many will be created? 4 partitions. And number of partitions is equal to number of tasks. I hope this clarifies thing. And you also should be able to understand why Spark is doing it. So that we have 4 cores, right? Why to waste one core? Right? Use all 4 cores and distribute less work to all 4 cores instead of giving more work to 3 core and one is sitting idle. Right? So Spark is doing this for us. Right? Now, there is one more concept. Again, we will learn later because I cannot teach everything together here. We will learn, but so here we are reading only one file, one big file, right? There can be a case where you are reading files from a folder, right? So there can be a folder and I want to read, let's say 100 files. In that case, behavior will be little different based on few more things, right? That we will see later. Okay, great. Now let me tell you again this size 128 MB, right? You will be wondering why it is 128 MB, why it is not 100 MB, why it is not 256 MB, right? You can change it actually. So how you change any configuration? You can just say set and then you can pass the value. So you can pass here in bytes, right? I'm not doing it, but you can do it, right? To get it, I get this. Okay, so this is 128 MB. Now you will say, why? What is this magic number 128 MB, right? So this is 128 MB has come after a lot of iteration R&D, right? So Spark recommend, right, that you should use 128 MB of partition size, right? If it is more, let's say 256, then you may have performance issues like out of memory and other things, right? And if it is less, let's say 50 MB, then you will have too many tasks and managing them will be difficult for Spark, right? So after a lot of iteration and all, they came up that 128 MB is the perfect size of your partitions and use this. Now you should not put too much mind why it is 128 MB. It is already researched and they recommend 128 MB. If you want to change it, you can always change it. It will create bigger or smaller partitions, but recommended size is 128 MB and you should not change it unless and until you have a very strong reason or something. Right? So mostly I think 99% of the pipelines runs with this default configuration of 128 MB and you will have 128 MB of partitions. Okay, great. Let me see if I have missed anything in my notes quickly. So this is fine. I enforced schema. Okay, this is fine. This is also fine. This we discussed. You can see this as well, right? If you want to see what is the default parallelism, this also show you, right? So let me just show this as well, right? This is giving me 4. So it will be number of codes, right? Let's do one thing just to prove my point, right? What I will do, I will go to my Docker file, right? And I will edit it, right? What I'll do, I'll give instead of 2 cores, I will give 3 cores, right? And we'll see the behavior then. So this is my worker one, right? And this is my worker two. I have given two cores currently, right? So let me save this, and I have given three cores, right? Driver is fine, doesn't matter. And now I'll just say compose down so that it reads the configuration again, and then up again. Okay. So let's see, have we got it or not? So I'll go to Spark Master, refresh it. Now you see there are three cores, nothing is used. As soon as I create the Spark session, it will say used. So it will occupy all the resources, right? So let me go back here, create a Spark session, right? And if I see this property, it should be 6. You see it is 6. Okay. Now you tell me how many partitions it will create for 1.1 GB file and for the 300 MB file. I'm checking the comment section, sorry, chat section. Go guys. Perfect. So people are saying 9 and 6, right? So you understand now, right? And let's do that. We don't want to be in uh, gas position. Let's do this. So what I will do is I will go here. Let me comment this and I will just say get num partitions. This is the one, right? Okay. So let's comment everything and just see number of partitions, right? Okay. So I'm reading 1 GB data. Now I have 6 cores, right? And let's see. So it is 9 as expected, right? Because again, the number of, so the max of this is, where is my calculation? In this case, 9 and 6, right? So it will create 9 partition. Here it will be 3 and 6. So it should create 6 partitions, right? So let's see. So let me change there itself. I'll just say 300 MB, right? And let's see how many partitions will be there. 6, right? So I have 6 partitions now. And let me run the job as well so that you see there will be a 6 task created and they will be doing some work, right? So let's do this. So it is done. Let's go here, go to jobs, right? This is my, so I closed the Spark session. So everything is gone. If you want to see previous jobs, you can go to history server that is at 18080 port. It will show you all previous jobs as well. And you see it's showing me 6 tasks, right? So each of the tasks, so there are 6 partitions and they are processing around 54 MB of data. I hope this should be crystal clear now that how many partitions, initial number of partitions will be created, right? So when I read a data set, how many partitions will be created, it should be clear, absolute clear in your mind. This is a very common interview question as well, right? I'm not teaching you here to crack interviews. I'm teaching you in-depth Spark that you can work. Interview is just a cakewalk, but I'm just telling you that this is a very common interview question that they will say that these many number of cores are there. This is the size of my file, single file. In case of single file, we have not discussed multiple files. In case of single files, how many partitions, how many tasks will be created. So you should be absolutely clear now, right? Great. So let's take 10 minutes of break, right? We are at a very important topic. I want to make sure all of you are clear. So let me know if you have any questions and then we will move forward and see a few more interesting things.
Yeah, Ankit, beneath this side. My first question is like, how did we configure the executor? As I see, there are like one executor per node. Is it also configurable, the executor?
Yes, we will see later. By default, there will be one executor per node. Later, we will see we can have multiple executors as well. But this behavior will not change how many partitions are getting created.
Okay.
Because
Second,
number of cores are not going to change, right?
right now, like we see just one stage right now. So in every stage, we see 9 all active partition. Let's say we have 2 stages. So again, in
No,
every
when
stage,
we reach 2 stage, we will understand. Don't discuss now. We have
okay.
only one stage so far. In what scenario we will have 2 stage? When we understand that, then we will understand how many partition will be there. Don't go there.
Okay. Ankit, one other question is, if you can open the Jupyter server once again,
Mhm.
there are two things I want to ask you here. I don't see the tab section on the menu icon, and on the left-hand side, this UI where you see all the options. When you read the file from the load slash data, so slash data is absent here, but how are you able to read there?
I think you didn't join the first session, is it?
I did join.
It is coming from here. We have mounted this data on the executors. This local system data folder, right?
Hmm.
We have mounted. So if you see, tu- 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 okay, let me open that. Yeah. So mm, open with text editor. And if you see this data folder, right? So we have a data folder inside executors as well. And we are saying that mount it on this. So the data folder inside executor is pointing to the data folder in my local system as well, right? So
Yeah,
whatever you put here, you will be able to read it.
sure. Thank you.
Yeah. Okay. Next,
Hi,
please ask
Ankit.
questions, guys. This is very important topic what we are discussing today. Go ahead.
Hi, now.
Hi, Ankit.
Yeah, Subramanya.
So I had a doubt regarding last class. So when you taught us the the overwrite this thing, right?
Mm-hmm.
When I overwrite the file, the files from my input folder are disappearing. Uh,
So you must have given the same folder structure. So you have to give, let's say, within data, right?
then I created an output this thing. I just wanted to understand why that is happening. Does it when you overwrite it like from my input data, it should overwrite the file, right? It should not delete those files from the input folder.
No. So let's say you are giving this folder, data orders, right? Right? Let's say this is your
Yep.
path, right?
Right.
Now, if there is anything within this orders folder, right,
Mhm.
it will just remove and write again in case of overwrite.
Okay, in that case, if you want to write it to the same file, you use append method.
Yeah, if you want to add those files, don't want to remove, then append. We will discuss this write API later in more detail.
Okay, so the behavior is because it is you're overwriting, it deletes the file.
Right.
Okay.
Yeah.
All right. Thanks.
Yeah. Next.
Hi, Ankit. Good morning.
Yeah,
Ankit, I have
Manoj.
one question about
Mhm.
when you shows that, can you go down a little bit, where in the allocation is, yeah. So when the task is coming up, no, here, you go back a little bit up. Here, when the task is coming on the course, 1, 2, 3, 4, so
Mhm.
this is going through any kind of algorithm or how Spark is deciding T1, T2, T3, T4 and all?
So
Any,
this is work of driver basically, right? So
Mhm.
driver will see that this is the size and it will decide how many partitions will be there, 9 or 6, based on whatever we discussed this, right? So now it will distribute the work equally to each executor,
Okay. So the
right?
distribution is doing through any algo or it is
It is just
deciding? Okay.
equally, it is trying to distribute. I don't
Okay.
know
Equally.
internally if they use some algo, but it is trying to distribute equally basically.
Okay. Okay. And one another question, like Ankit, like when you given up a file where we have to generate the data, I
Mhm.
am not able to generate those set of data. Can we get the same set of data which you have it?
You just
Uh,
have to run that script.
I've run it, but it
Uh,
is not giving a successful on. Then
what is the error? You should be able to fix it, right? You are going to be, or you are a data engineer, right? Even if you are facing
no,
some
I
error, you should be able
no
to
no
fix
I
it.
fixed that error.
Hmm.
It is generating only. I'm not getting that result. It is showing me just generation. That's it.
No, so what will happen is, where is my script? Where I kept my script. So let's say you kept your script here, right?
Mhm.
So what will happen? It will create a orders data folder within that.
So I have to keep the script here, correct? You're saying
Anywhere you
setup.
can keep, right? So let's
Uh-huh.
say you are keeping a script here. Maybe I would have generated somewhere Python code. This one. Yeah, so this is my script, right? So when I run this script, it has generated this folder, and within this folder, it will create the files. So you just copy from here and put it into data folder.
Okay. Okay. I'll try once again on
Yeah,
this
yeah,
to
yeah.
generate the
So
data.
sharing this 1 GB, 2 GB file is not easy, right?
And
So
I
you
think
should
no. I am saying is if you put it in some GitHub or something.
in GitHub,
Anyways,
there is
I'll
a
try
limit
once
of
again.
1 GB file actually in GitHub. You cannot upload more than 1 GB. And I'm going to produce
Sure.
2 GB, 4 GB of
And
file in future.
I can using ChatGPT also to create and generate, correct?
I don't know.
You
So
can ask in
ChatGPT will
Telegram.
not create 1 GB data. It will just give you a script, right? I don't think. But I think it should work. I mean, you should be able to fix it, I feel.
No. I am able to fix it, but
Yeah.
it is still in progress. Like it is showing 5-10 minutes in progress, but the data is not generated. But again, I will try
Maybe
once
try
again.
with less number of rows first.
Okay. Okay. I'll
Okay.
do that one. Okay.
Yeah. Yeah. You should fix it. It will help you in future as well to generate any size of data, right? So don't rely on ChatGPT and all. Okay. Any other
Yeah, hi
doubt?
Ankit. Yeah, hi
Yeah.
Ankit.
Yes,
So
Rohit.
I have two questions. The
Hmm.
first question is that right now when we change from 4 cores, so your system is I think 4 cores and you switch to 6 cores. So
No, my
core is the
system has
hard.
10 cores. My system has 10 cores, right? Earlier I assigned
Okay,
two cores to each worker. Right?
okay.
You
Now,
should
now
see. If in your
I
system
got
you
it.
have only 4 cores, you should not give three. So you have to check your system and accordingly you tweak. Or maybe you give one code and see how it is behaving, just to see.
Okay. So no, Chikit responded. My question was that if the code hardware is restricted, so in your case, 10 cores is your maximum number. You can't make
Yes.
it 12, correct?
Right.
Okay. Okay, fine. And second question is that in your system, you have given nope and OOP, no operation something. So in this
Yeah.
case, actual write operation is not happening. That's it, correct?
Yeah. Files are not getting written, but everything else is happening. All the plan is getting generated, all data processing is happening. It is just that it is not writing file in my system.
So in this case, are you saying the partition, everything will also happen?
Yes, everything is happening. All the processing is happening.
Okay. Okay, perfect.
You
And
can
third
even
is
write
that,
it. That's fine. It will just overwrite every
no,
time.
this is good one. This is good
Yeah.
thing. I don't know this one. This was
Yeah.
something new for me. The third thing is that I can see people are writing the code in GitLab or GitHub, and then the how we integrate this Jupyter with GitLab? Maybe not the
GitLab.
right time to ask this now. Yes.
Yeah, maybe later I can
Okay.
show you.
Okay. I will. Yes. Fine.
Yeah.
Thank you.
Yeah. Okay, next we'll take two more doubts and then we'll take doubts at the end. Yeah, go ahead, quick.
Yes. Hi, Angit.
Yeah.
Yeah. So I could say so. Whenever an action is invoked, a job is created, right? So we are using infer schema and also enforced schema. So enforced schema is taking time. So and also I could say and it's an action, right? The job is created when we use infer schema, and for enforced schema, so the job is not created.
Yeah, I'll
Because
just
it is
explain you.
taking very quickly,
I
right?
missed that part. I'll explain it after the doubts. Yeah,
Mm,
I missed
okay.
it. Sorry for that. Yeah.
Okay, and one more question. So when regarding that dry run, so why we have overwrite mode? Because for dry run we are not writing or not saving the file, right? So why we need overwrite mode here?
It
Is
asks
that
for
mandate?
overwrite actually. If I don't give, it gives me error. So
Okay,
basically,
is that
it is
we
mandatory. For no operation, you have to give overwrite actually. Yeah.
okay, got it.
Yeah.
Yeah, thank you.
Yeah. This is kind of a dry run. Yeah.
Yeah,
Okay.
Ankit.
Yeah. Advik.
Sorry, Achan, this is my like kid's name. He's using it for like
Yeah,
his
yeah. Go
online
ahead.
class. So yeah.
Yeah, yeah.
So the question is, Ankit, like you use like 3 MB, 300 MB file, and it does not have any like column names. So when you were checking the data frame, the names were there. So I want to know like how it the columns name like got pushed. Is
We
it
are
through order
passing
schema?
schema. We are passing schema, right?
Okay, so it just took by the sequence.
Yeah.
Okay.
This is the whole purpose of giving schema, right? To give
Okay. If you
headers as well as the data types.
so if you don't have the column names, it will like push automatically through order schema.
Yeah.
Okay.
If you don't pass a schema, then it will give something like as C1, C2, C3, some random numbers.
Got
Yeah. Okay, great. So we'll take rest of the doubts at the end, right? I want to cover a few more things before we end today's session. Okay. So now what I will do, so we understood, right, that for each action there will be one job created, and we saw that, right? In this case we have one action, right, and one job is getting created, right? And again I will explain that what is laziness and what is action, right? So we are saying transformations are lazy, which means when I read this, when I run this command or run command this command, nothing is getting created. I will just show you, right? So I'll just run this much and I will go here, jobs. So there is one job, 0. There is nothing else, right? You see only 0. Now I will run this where I have saying order schema is this, df orders this, and filters this. There is no action, right? I have not applied any action. It immediately ran. It didn't take even a second, right? And if I go there, nothing new. There is only one job, that previous job, right? This is meaning of laziness, right? Unless and until I apply any action, right, it will not do anything. It will just create a DAG in the backend that what has to be done. But only when I apply a action, it will create one job, right? Also, don't think intermediately it is creating multiple data sets. No, it is not. It is not that it is creating DF orders. It is also creating DF orders filters. No, there can be hundreds of transformation. It doesn't mean it is creating so many RDGs or data set in between. No, it will just chain all the transformations and run it in one stage, right? It will just chain and run everything together, right? So it is not creating these in between. It is just getting added. All of this is getting added to the transformations, right? You can even chain it. So you can just directly say this, right? This will also work. So you can directly say this, that filter it, and whatever is filtered result, then write it. This will also work. This will also work. So I'm just showing you that some places you will see people have chained multiple transformations together, and some places people have created multiple, but plan will be same, right? Ultimately. Okay. Now what we will do a thing, right? So we will not pass a schema. for now, right? And again, we will run this. So we will say infer schema equal to true. So I'll say dot option infer schema, and let's say true, right? And this is my 300 MB file, and I don't have a header in this, right? So let's see. Okay, or let's take 1 GB file, that's fine. Okay, so what I'm doing now, I'm not using this order schema. It is just written there. I have commented it, if you see, right? Let me remove it completely so that there is no confusion. And just for continuation, I have to put this, and let me put it here. Okay. So I'm just saying that infer schema is true. So infer the schema, I have the header, and this is my file, right? And I'm filtering it and writing it. And let's see what will happen. So let's run this. It is running. There is some error. It is saying, what is the error? States cannot be resolved. Okay. States is not there. Okay, let me check. Let's do this. Print schema. Okay, so we have state, not states. Okay, my bad. State. Okay, let's go back here and we will write it. Okay. So again, we are just reading the file, doing some filtration, and then I'm writing it back. Great. Okay, it is running. It is done. Okay, let's go back here and see how many jobs are getting created. So if you see, 2 jobs were created, right? Let me maybe clean it, otherwise there will be confusion. Let me stop it. So I'll say spark.stop and start a session. Go there, refresh it. Nothing is there now, and I will just run it again, right? This part. Okay. Let it run for a few seconds. Yeah, it is done. Right? Let's go back and refresh it. Now, if you see, it has created multiple jobs, right? Why? Because it is creating extra jobs for inferring schema, right? So if you say infer schema, it will create extra job. It should create 1 job. I'm not sure why there are 2 jobs. But ideally it should create 1 job for reading the schema and 1 job for the action, right? So this is the job basically for the action, right? It is reading it and filtering the data, right? So whenever you say that infer schema, it is going to create 1 more job to read the data and infer the schema, right? There should be 1. We'll see why it is creating 2. I'm not sure, but there should be 1 basically. 1 for inferring schema and 1 for this write action, right? But in real time, you will not use this infer schema, right? You should not use, right? You should always give the schema instead of saying infer it. And now it will create only 1 job. Okay, so this is all fine. Again, it is giving me error. State cannot be resolved. Um, Oh, I got it. So here it is states actually. Okay, when I was inferring a schema, it was taking state from the file, right? Now when I pass states, it is taking state. So let me take change it to state now. Now it should be fine. Yeah. Yeah. Now it is fine and it will create one job. So it will create only one job. You see, this is our old job, 3 jobs, and this is one job it has created. Okay. So basically, infer schema creates one more extra job. And in ideal case, in production, you don't want to do that. You always want to pass the schema. Great. So we understand these things, that each job, each action creates one job. Number of partitions will be as per our rule, right? Max of 2 things, right? And number of task will be number of equal to partitions. And as per how many codes are there, our that many tasks will run parallel. And once they are finished, then next set will come. This we understood with this flow as well. And this should be clear now. Great. Now, when we talk about transformations, right, there are 2 kind of transformations, right? So one is transformations and action, that we understand. That action is when we need something, right? So for example, when I say collect or show or write, these are actions. So whenever I say action, then the job will be triggered. Now within transformations, there are 2 kind of transformations, right? So when I say transformations, there are 2 kind of transformations, right? Okay. Now, before I discuss these 2 kind of transformations, let me ask you one thing, right? So I will take this code and write something. So let me do this. So I'm saying read this, all of this, and then I'm saying instead of filter, I'm saying do group by, right? Group by means aggregation we are doing, and I want state-wise sales, right? So I want state-wise or maybe count number of records, right? Let's say I want number of records for each state, right? And let's say grouped, and I'll say group dot show. Let me comment this. Okay. So what it will do, it will count number of for each state, how many records are there, right? So let me run this. So it is showing me for Karnataka, these many records are there. It's okay if you don't understand the syntax. It is just like select group by of select, sorry, SQL, right? We are grouping on state. So all states are coming together and we are counting number of records, as simple as that. For Odisha, this and this and that. It is showing 20 rows. I think we have more than 20 states or whatever. Now you have to understand one thing, right? So let me go back here and I'll tell you what is the problem now. So let's say I have 9 partitions now, right? We understand we have 9 partitions, right? Let me take here a little bit. So let's say this is my partition 1, right? And then I have partitions 2. I'm just creating 3, but we can have 3, 4, 9 based on the data, but I'll be able to explain it, right? That how these things is happening. This is my partition 3 now, right? Okay, good. Now in partition 1, right? Let's say I have orders of, let's say Karnataka. Karnataka. Let me put order ID first. So I will say order ID 1, right? Let's say Goa, and the sales is 200, let's say. Simple, right? Then I have order ID 2, right? This is, let's say, UP, and let's say the sales is 300, right? Okay, this is fine. Okay, fine. Let's say there is one more record, right? Then again we have Goa, and let's say 100. Okay. So in partition 1, this is my data. Great. In partition 2 also, we can have all the states of data, because when it is creating partitions, it is just creating. It is not telling that in this partition, this state data is going, or this order status data is going. It is just creating randomly, it is splitting the file, right? So in this, maybe we will have 4. Let's say Goa is again there, and then let's say we have Maharashtra, right? And then we have UP, right? And this is 4, 5, 6, right? And in partition 3 again, we have some more, right? Let's say 7, 8, 9, right? And here, let's say we have Karnataka also, right? And we have UP and Goa. This is how my data is. So I have created 3 partitions, and let's say this is the data. Now, when I do group by, what will happen? Will each partition be able to give me the result? Can I say that group data, if these partitions are just running independently, this will produce some data, right? So this will say Goa, common number of records is 2. I'm doing count. UP 1. This is what it will give. First partition. Great. Right. Second partition, what it will give? It will give me Goa 1, Maharashtra 1, and UP 1. This will give me this. It will give me Karnataka 1, UP 1, and Goa 1. Right? And if I show this in output, right, then it will be wrong. I will have 3 records of Goa. In my output, it will be data like this: Goa 2, UP 1, Goa 1, Maharashtra 1, UP 1, Karnataka 1, UP 1, Goa 1, and it will be wrong, right? So this is how it will not work. It cannot independently, each partition cannot independently say, okay, this is the total count of Goa, this is the total count of UP, right? When I was doing filtering, it was okay, right? When I was doing filtering, they can individually filter. Let's say my filter is give me sales greater than 200. Give me all the records where sales is greater than 200. In that case, things would have been fine. Don't you think? Right? So if I filter it, it will say, give me 2 UP 300. Right? I want sales greater than 200, right? This will give me, let me take this. This will give me these 2 records, this Maharashtra only, right? Greater than 200, it will give me this. Right? Similarly, this will give me 1 record where it is 8 UP 300, right? I want greater than 200. So in case of filter, they were able to independently work and give me the final result, and there is no issue. This is the output I'm expecting. When I'm applying a filter, this is the final output, 3 rows I'm expecting, isn't it? And it would have been correct. But in case of group by, this is wrong. Right? Now, what is that one thing different in group by, which is not in filter? Right? The important thing here is that in group by, the column on which I am grouping, let's say grouping key, the all values of those grouping key should go to one partition, then only it will work. Right? Independently, if I'm executing, it will give me wrong result. Filter will work, right? Filter will work because it is independent. When I'm applying filter on this row, it doesn't matter what data is there in partition 2, what data is there in partition 3. But when I'm doing group by, it becomes important. All Goa should be in one partition. All UP should be in one partition. All Maharashtra should be in one partition. All Karnataka should be in one partition. Right? So how it should be, right? So let me move it a little bit right. Right? So how it should go? We should have new partitions created, right? In that, I will say move everything. Goa 1, sorry. I will say this is my partition 1 and move all Goa here. Sorry. Right? And we have one more Goa here. And we have one more Goa here. So all partitions sorry, all Goa should go to one partition. Now I can aggregate and say Goa, comma 4. Until and unless all Goa are not there in one partition, I will get the wrong result. So again, let me put it everything so that you are not confused, right? In the second partition, let's say all the UP are there. Let me copy UP, and then one more UP. Okay, so all UP are going here, right? Now, let's say we have one more partition, right? And here, let's say UP Goa, Maharashtra is gone, is there, so Maharashtra. Now, it is not necessary that each partition we will have only one key. We can have multiple keys, but all the keys data should be in one partition, which means in this partition, I can have Maharashtra, right? All the records of Maharashtra, and I can also have Karnataka, right? But one key should not be there in multiple partition, right? So if you see Karnataka, Maharashtra is there in one partition, which is okay. But all the records of Karnataka is in one partition. All the records of Maharashtra is in one partition. All the records of UP are in one partition. All the records of Goa are in one partition. Now, if I do aggregation, I will get the right result, right? This will give me 200, Goa 4. This will give me UP 3. This will give me Maharashtra true, Karnataka 1, and that will be the right answer. Now, this process of moving data from this partition to the new partition is known as shuffling, right? This process is known as shuffling, right? Shuffling means I'm moving data from one executor to another executor, right? Each executor is a container basically, right? Each executor is one machine, right? Now, what you have to do, you have to move data from one machine to another machine, right? And this is a costly operation until and unless we were working with an executor, right? If partition 1 is one executor, I was not taking this data to executor 2. Or if this is in executor 2, I was never taking it to executor 1. It was in those executors and they were just doing happily everything. Now I am saying group the data on state. Now they cannot do it. So we have to move data from one executor to another executor, and this is known as data shuffling. Now, when shuffle is happening, it cannot happen in memory. So these each partitions, right, will be writing data to disk of executor, and from disk, then they will go to another executor, right? So there is a disk IO involved. It is known as shuffle read. Shuffle write. So these will do shuffle write, right? And new set of partitions will do shuffle read, right? And after every shuffle, a new stage will be created. Right? We have discussed so many things, but when we see on UI, it will be clear. Right? So let's see the plan. Okay. So I'll just go here. Let me do this. Okay. One more thing before I go there. So we have 3 partitions here, right? Now, how many partitions will be created after the shuffle? Right? It will not be 3. Right? By default, Spark will create 200 partitions. Right? After shuffle, by default, Spark will create 200 partitions. Again, we have a configuration I will show you. We can change it. But by default, Spark will create 200 partitions after shuffle. So let me run this and I will say, just to see the full plan, I'm doing a write. So I'm reading the data, right? I'm grouping it on state and then I'm saying write it. That's it, right? So let's run this. Okay, so there should be only, I'm saying schema I'm giving. So there should be only one job, right? So we have 3 jobs so far. Okay, we ran multiple things in between, right? This is the job we just ran. See, it is 457, before that 456, right? So this is the job we ran, right? It shows 2 stages. So far it was showing one stage, whatever we have done, right? Now it is showing me 2 stages. You see, this exchange means shuffle. When you see in this DAG exchange means nothing but shuffle. So we are shuffling data from executor to other executors, right? And this is a costly operation. And for each shuffle, it will create a new stage. Every time you do a shuffle, it creates a new stage, right? So if you see, there are two stages. First stage has 9 tasks. Why 9 tasks? Because we have 1 GB file. There are 9 partitions and they 9 are creating 9 tasks, right? And they are after shuffle. I told you that Spark will create 200 partitions. If you see, Spark has created 200 partitions, right? Now, if you see, most of the partitions are empty. You see, we have 200 partitions if you just keep going, keep going. But most of the partitions are empty. Only how many partitions will be there? If let's say I have 20 states, then maximum 20 states can have data, 20 partitions can have data, right? Because for each state, right, all data should go to one partition, right? So all Goa should go to one partition. So if I have 20 states, let's say, then maximum 20 partitions can have data. It can be less because two states data can go in one partition as well, right? But here, what I'm saying is most of the partitions are empty. Only these partitions are there. So if I get to see till here, only I have data. So I have, I think, how many? This is around 20, right? So around 20 partitions have data. I think 19, right? Everything else is empty, right? So we will see how we can reduce this partition, but we have a property for that. So I'll just show you this property, right? So this is default to 200. Where is my, okay, let me write here. Spark.conf.get. You see 200, right? And one more thing, right? If you have done some other setup, not followed my setup, right? Then I just want to show you something that I go to desktop, conf, so I have put some configuration here, right? So it will override the default configuration, whatever we have. So here I have done this adaptive enabled false. By default, it will be true. In Spark version after 3.0 or 3.1, this is by default true. I have done false for some purpose, right? So if you are also doing somewhere else, not following this setup, then you should make sure you do false. I'll tell you later what happens when we do true, right? And there's one more property. Its value is 10 MB. I have done -1 for now. Later we will change and see. So default values of these two I have changed. This is by default 200 only, and I have also given 200, but I can change it. If I change to 100, it will create 100 partitions after shuffle. Okay. Now this brings me to one thing, that there are two kind of transformations. One which will not require shuffle, right? Right? They are like filter, right? Filter doesn't require shuffle. You understand it. And second kind, which requires data shuffle, right? For example, group by. We will see more example of it, right? And these kind of, this category has some name. These are known as narrow transformations. And these are known as wide transformation. Right? So if shuffle is not required, each partition can individually work and give me the result, right? So it is narrow transformation. One example is filter. Any transformation which requires data to be shuffled, right, within individual partitions cannot give you the final result, right? Individual partitions cannot give you the final result. They have to shuffle the data so that each key is go to one partition, right? Those kind of transformations are wide transformations, right? Like group by. Okay. So I think there should be a definition. Narrow transformations, each output partition is derived from exactly one input partition. Data is processed locally within same executor, so no data movement happens. Multiple narrow transformations can be pipelined into single stage, right? Select, filter. We have not discussed all of this, but you understand with filter that why it is a narrow transformation. Each output partition depends on data from multiple input partitions. Spark must redistribute data across executors, which triggers a shuffle. Wide transformations break stages and are most expensive operations, like group by, join, order by, distinct. Right? For now, you understand with group by. Right? So every wide transformation creates a new stage. Number of stages will be 1 plus number of wide transformations. So in our case, group by is a wide transformation. So one stage will be created by default when we read a file or something, anything we are doing. The moment you apply a wide transformation, one more stage will be created. So in our case, it will be 2. So number of stages is 2. 1 plus number of wide transformations, right? So we see the 2 stages for this job, right? So for this job, we see 2 stages, right? And this is stage 1, this is stage 2, and there is a shuffle. It is showing. Exchange means shuffle. Wherever you see exchange, it means data is shuffling from one executor to other executors, right? And I said that it has to write data to the disk, right? So let me show you here. So here data shuffle is happening. So it has to write data and then it has to read data, right? So it is saying this stage has written some data. Shuffle write is 13.6 MB. And this stage is reading this data now, right? Shuffle data, it is reading, right? So it is 13.6 KB, it is reading, right? So you can see how much is the shuffle write and same will be the shuffle read in most of the cases. Right? So now you can imagine this first stage processed 9 partition and it has written that data to the disk, which is shuffle write. Then this stage, next stage, it will have 200 partitions by default, right? And then Spark will read that shuffle data that this stage has written on the disk, right? And then it will read it and process it further. So that's why you see shuffle write and shuffle read. Now slowly we will understand all the terms that you are seeing on UI, right? So this was the input data around 1 GB and this is the shuffle write because it doesn't have to write everything, right? We need just the state and the count. So it is not 1078 MB because it needs only one column or two column. So it is writing only that data. It is not writing full data, right? If you require two column for the output, it will just write that one. It doesn't need all. It just needs state and number of records. That's it. So shuffle write is not 1078 MB. It is just 13.6 KB. Okay. I hope this makes sense. Okay. So when we learn transformations, we will keep talking about that which is a narrow transformation and which is the wide transformation. Right. For now, we understood with filter why filter is a narrow transformation and why group by. So any transformation where you think that all keys should go to one partition, then only I will get the right result. That will be the wide transformation. And you think logically, you should not by heart it that filter is narrow, group by is wide. You should not by heart it, right? You should logically think, okay, when I'm applying filter, do I need to shuffle data or individual partitions can give me data? If they can give, then it is a narrow transformation. When you think about group by, okay, we are doing group by on, let's say, department, right? So all same department data should go to one partition, then only I will give right result. So you will think, okay, this is a wide transformation, right? So this is how you should think about it, and we will keep talking about it. We will learn transformations, different kind of transformations, and every time I will ask you, it is a narrow or wide, you think, right? You don't have to by heart it. Okay, and about transformations and actions, right? Everything is transformations. Only there are few actions when we ask for data. For example, show, collect, and write. I think there is couple more. Let me see in the notes. Uh, so, count is also there. Yeah. When I say count, it will give me the number of records basically. We'll talk about count. Count sometimes behave as a action, sometimes behave as a transformation, right? We will see. But for now, when I see count, it will trigger the job. Let me show you quickly. So we have job ID 9, and let me go there and say df orders dot count. It is returning me the count number of records, right? To 20 million records, I think. And if I go there, it will show me one job. Job ID will be 10. Yeah, you see, one job is getting created. And count is also triggering a job basically. Okay, great. Now let's move forward, and I wanted to show you one more thing. We understand narrow transformations, wide transformations. Okay. Now there is, if you think about it, right? If you think about it, Spark can do some more optimization when we are doing group by, right? Just think about it. So let's say this is my data, right? This was my data, right? Now what we are saying, let me take it little right. We are saying that shuffle all the data, right? So we are saying that take all the Goa and move it to a one partition in next stage. Take one Goa 200, 3 Goa, from here 4 Goa, and from here 9 Goa, right? Great. Then again for UP, you take this UP, this UP, and this UP, right? And then again for Maharashtra and Karnataka, you move here, right? Now you think about it. You are saying, give me count of records or sum of sales. Don't you think Spark can do first the local aggregation? So the shuffle is less. The lesser the shuffle, better it is. So instead of shuffling Goa 200 and Goa 100, right? What it can do, it will aggregate for each partition locally. So what it will say, instead of shuffling Goa 200, Goa 100, I will do a local aggregation, right? So I will say Goa, let's say we are counting number of records. So Goa 2, UP 1. Instead of finding Goa 1 and Goa 1, right? In this case, we have to have 3 records that we have to shuffle, right? If we are not doing local aggregation, it will just say Goa 1, and UP 1, and it will send it, right? Now, what we are saying that, okay, before shuffling it, before sending it, before writing it to the disk, why don't you do local shuffle? First you do local shuffle, right? And then we will do, so instead of like this, how it will be? It will be like this. So we will have Goa 2. Let me remove it. Right. So we will have Goa 2, right? And from here it will be coming as Goa 1. And from it will be coming as Goa 1. Right? Right. So in that way, what will happen? I will have to shuffle less data. Right? And once I have all the Goa in one partition, then I can further aggregate again 2, 1, 1, 4. So I will do aggregation 2 times. Once when I'm writing the data at each partition level, I will aggregate the data. That okay, in this Goa 2, UP 1. In this Goa 1, Maharashtra 1, UP 1. In this again Karnataka 1, UP 1, Goa 1. Right? And then that data I will write, aggregated data, and then next stage will read that data, right? So in that way, we will have to shuffle less data. We are talking about 2 or 3 records. Imagine if I have 1,000 records of Goa. So instead of shuffling 1,000 records from one executor to another, I will end up shuffling only one record, Goa, 1,000. Right? If in this partition I have 1 million records of UP, right? If I don't do local aggregation, I will have to shuffle 1 million records of UP from here to here. What I will do, I will do local aggregation for UP. This is the count, and then send it. right? And then I can finally do aggregate 2 plus 1 plus 1, 4. Right? So this is how it will do. So we will see this in action, right? So let's go there and run this again. We'll just run this again and see what is happening. Okay, now in actual, what would be happening, right? In actual, I have partitions of 128 MB, 128 MB. Now, most probably, right, I will have all the states data in each partition. So let's say state 1, state 2, sorry. Right. Maybe in partition 1, I have, let's say, 100 records of state 1, or let's say 1000 records, right? And of state 2, I have, let's say, 2000 records, right? And similarly, most probably in each partition, I will have all the states, right? I have 1 GB file and I am creating 128 MB data, and it is a random generated data. It is not that all the Karnataka will be together or something like this. So most probably each partition will have each state of data. So each partition will aggregate data at state level. So if let's say I have 20 states, so these partition will just write 20 records, isn't it? If I have 20 states, right? If I have 20 states, this partition will write only 20 records. It will say for state 1, there are 1000 records. For state 2, there are 2000 records. For state 3, right? Similarly, partition 2 will also write that. And then when shuffle is happening, we will again aggregate and give the result. So let's see, right? So I have run it or not. Let me see. So this is my job 10. Yeah, I just ran it. Yeah. Okay. Now if you see, right? Let me go inside this. So this is my first stage, right? So if you see, it is writing 22 records only. You see, because we have distinct 22 states. I can show you. So just to make sure we are not doing anything wrong. So I'll show you DF orders. Right? I am writing some code. It's okay if you don't understand. Dot select state dot distinct. Let me run this dot show. So these are the states we have, and let's see the count. How many distinct states we have? You see, 22 distinct states are there. So each partition is aggregating data for each state, and then it is writing. It is not writing all the 128 MB of data to disk, right? Isn't it a good optimization? Because shuffle is costly. You are moving data from one system to another system through network, and that is costly thing. So what Spark will do, we'll do local aggregation first. Whatever I can do at individual partition level, let's do it. Then I will shuffle it, right? So if you see, only 22 records. Each partition is creating 22 records, right? Exactly 22, because each partition would have all the state data. Now this will be shuffled. That's why you see shuffle size is so small. Only 22 records it is shuffling. We have 20 million records, right? And we are applying group by on all the data. We are not filtering anything. But if you see, only 22 records, because for each state, it is doing a local aggregation first at each partition level. Then again, they will do shuffle. Each state data will go to one partition, and again it will do aggregation, right? You can even see this here. You see, it is doing an aggregate. So it is scanning the file. It is doing a local aggregation first. You see, clearly it is visible, right? And then it is doing a shuffling. Exchange means shuffle records, right? And then it is again doing a aggregation again, and then it is giving me the final output, right? So this is how you have to understand that how group by is getting optimized by Spark. Okay, we'll discuss more about these things, but at least at the very conceptual level, you should be able to understand. Okay, it is showing me 3 stages. Why? Let me see. Where is my job? Okay, I'm doing count here. That's the problem. Okay, I should not do count. Oh, I should do count. Sorry. Why it is showing me? There should be 2 stages. Here, let me see what it will give me. Nothing, right? It should show me 2 stages. Why there are 3 stage?
With every data frame, we can try get num partitions and see.
Sorry?
With every data frame, we can try the get num partitions and see where it is increasing.
No, it doesn't matter, right? There should be 2 stages. Let me run this again. Maybe, let me see. Jobs. So we have till 17 jobs, which is fine. Let me run this again. Okay. Job ID 19, 2 stages. I don't know what we did here. I don't know what we did here. I ran something else as well, I think. Print schema or something. I don't know. But there should be 2 stages. It is clear here, right? There are 2 stages, right? This one and then after shuffle. And here also, if we see, right? So now it is clear that we have a local aggregation, then data shuffle, and then again aggregating after the data is shuffled, right? I want to show you one more time clearly, right? So it is like this, right? We are doing a local aggregation first, right? So let's say this is my partition 1. Let's understand with 2 partitions, right? So this is my partition 1, partition 2, right? Let's say partition 1 is saying state 1 has 1000 records, state 2 has 2000 records. Again, partition 2 is saying state 1 has 1000 records, state 2 has 2000 records. Now data shuffling will happen, right? So this is your new partitions created after shuffle. There will be 200, but let's see. Now what will happen? We will make sure that state 1 is going, let's say this is not 1000, let's say it is 1005, right? And this is, let's say, 3000. Let's say this is 2000. Right. So from partition 1, for state 1, there were 1000 records. So it aggregated data written to the disk. Then this is partition 2. It has 2000 records of state 1 and 3000 records of state 2. Now when shuffle will happen, what will come here? It will come as state 1000, right? From partition 1 and state 1, 2000 from this partition, right? Similarly, here it will come as state 1000, sorry, stage 2, state 2, 2000, right? And from here it will come state 2, 3000, 2, 3000, right? And then it will do the aggregation again. It will do aggregation again and it will give me state 1, 3000, state 2, 5000. So 2 times aggregation is happening. 1 time here within the partition. Once shuffle is done, then I want to produce the final output and it will give me state 1, 3000, state 2, 3000. Okay. Great. I think that is it for today. I wanted to discuss the join as well, how join will behave, right? But we will keep it for tomorrow. Let me see if anything I have missed. Yeah, this is all fine. Internals of joins we will see tomorrow. Okay. Great. Okay, let me know if you have any questions.
Hi, Ankit. I
Yeah.
have a question regarding the number of stages that will be created. So let's
Yeah.
say there are 10 wide transformations,
Hmm.
select and one write operation. So how many stages will be created? 12 or will it be more than 12?
It will be 1 plus number of Y transformation. That's it.
1 plus number of Y transform. So collect and write won't give two stages separately, is it?
No, collect and write does not create new stage.
Oh, is it? Okay.
Yeah.
All right,
Collect
fine.
and write are actions, basically. They create job.
Okay.
Yeah.
Okay. Fine. Thank you. Thanks.
Yeah, hi Ankit.
Hmm.
So just to reiterate,
Mhm.
can you go to UI? So you have told us that the smallest unit is work, and inside work there are a lot of tasks which is called partitions.
Mhm.
So jobs is the top level, right?
Hmm.
And
Correct.
inside the jobs comes the stage.
Right.
So in this case, what I think Anup has asked, so collect, write. So if you are adding, say, collect and write, that means
Mhm.
two jobs will be created.
We are writing write only. We are not writing collect. If you write collect also, then two jobs will be created separately. One for collect, one for write.
So
We
in
are
this
just
case, for
saying
example, we have count and write. Correct. Count in an action,
no.
write is also an
Here
action.
it is not an action. We'll discuss. Here it is a transformation. When you are using the
Okay.
group by, it is a transformation, not action.
Okay. For example, just write collect. So in case we write it collect, that means
Mhm.
two jobs will be created, correct? One
Right. So
for
if
collect
I
and one for
write
write.
collect here, right? Let me write collect. Right. Let me write. But collect will, it will not have much data. That's fine. It is aggregated data, right? Okay.
Yes.
So I'm writing two, or let me show you this, right? First. Okay. So we have job ID till 18, right?
Yes.
Let's go here. Now I'm doing a write as well as collect, right? Same data. So this is DF orders group. This will be grouped on state, and there should be two jobs now.
Mhm.
Okay, so collect will give me the result here, right? And if I go here, we have till job ID 18, right? See, we have 19 and 20, right?
Okay.
So what
And
is happening here is these are two different jobs. So what it is doing? See, this is a lazy transformation. So this is not doing anything anyway, right?
mhm,
So
mhm.
when you say write, it will pick up the DAG. Okay, this group data is coming from DF orders, and DF orders is, so this is my DAG, right?
Mhm.
For the first action. Then again, it will pick DF orders group. It will again go there, see the what all has to done, and it will do everything again. So for both, the plan will be same. You see,
So,
209 partition, two stages. So it is kind of two separate jobs we are running.
okay. And second thing, thanks, Ankit. Can you go to your that diagram?
This one. Okay.
Yes. So this is exceptional one. So in this case, when we are going from, can you scroll up slightly,
Mhm.
please? Yeah. So this partition 1, 2, 3, then it is going to a local, which are we saying as a local shuffling, or is because within the partition it is group by is happening, correct?
Yes, within the partition in memory, aggregation is happening. And then
So
it
we
will write it to the disk.
right. So as soon as the writing to disk is comes in, then the exchange word or the fetch which you said that comes to the picture, correct?
Yes, yes.
So when it is doing within the partition, what it is called? It is called local shuffling or local aggregation.
It is local aggregation.
A local aggregation. Now,
Yes.
if you scroll, now in this one we got it local aggregation. Now at the end, we can see in the second last column, Karnataka one, UP one, correct? So in the third, I think the fourth one, the Goa two and UP one. So
Okay.
this is after shuffling, we are
Yes.
getting one more stage, and then the final aggregation happen, correct?
Right. You think like this. This is simple one, right? So let's say this is your initial partitions, right? This is
Right.
your
So
initial
we should
partition.
should call it as aggregation shuffling, local shuffling. Sorry, a local aggregation, shuffling, then final aggregation.
Right, right. Exactly. Right. So this is your initial data. I'll explain again, right?
Mm-hmm.
Now what it will do within each partition, right? It will do the aggregation. So this will give me, let's say, state 1000 times, state 2 2000 times, right? Again, this partition will give me state 1 2000, state 2 3000. Again, this partition will give me whatever, state 1 2000, state 2 3000, right? This is local aggregation is done now. Now it will write the data to disk, and then next stage will read that data. And now during shuffling, right, this state one, all of the records will go to one partition. State two will all of to go to two partition. And by default, it creates 200 partitions. But it doesn't mean all 200 will have data, because we have only 22 states. So maximum 22 partitions can have data. It can be less because one partition can hold two states data also, state one, state two both. But maximum 22 partitions can be busy, right?
Correct.
And later we will see how we can optimize, because this is unnecessarily why Spark is creating 200 partitions, right? We will see later how we can optimize it.
No, you have already covered this one. I was asking why, as you explained earlier, 4 cores, 3 cores to 4 cores. Okay, that means here also this is happening. Fine. And the last bit, the question which I asked, that silly question, how to integrate that Jupyter with my GitLab? Because I am seeing people are writing code in Jupyter, then they push to GitLab, means GitHub, I mean to say.
Maybe you can check some video. I also need to check. You can check some video on YouTube.
Okay.
Yeah.
Okay, no problem. No problem. Cheers. Thank you.
Okay, next.
Yeah, okay.
Yeah,
So-
before you ask doubt, I just want to tell you that this was the one of the most important session of our Spark bootcamp. If you don't understand this, you will not understand things, right? So if you think it is not clear, please watch the recordings again. Do things your own. Generate files, play with it. 1 GB file, 300 MB file, change the number of codes and see how many partitions are creating. Do shuffle transformation and see how many is creating. Is local aggregation happening? Everything you should see by yourselves. Then you will get the confidence. By seeing me, you understand it completely. But to get that confidence, you have to do it yourself, right? And there's nothing very high-fi I taught you. Very basic things I have taught you. If you just spend 2-3 hours after today's session, these things will be clear. So your Spark fundamentals will be very, very strong, right? Okay, go ahead.
Yeah, thank you. So my first question is, when we run any action in notebook or at any place, it shows that 4 of like some tasks are running or stages are running, right?
Yeah.
So from the UI, it is understandable after this session that okay, what are the current tasks are running, stages are running. But from this part, how we can understand, okay, that I understand that total 10 maybe tasks are there and 4th is running, then 5th is running, something like. Can you show maybe that how we can understand that?
You don't have to understand from that.
Okay.
It gives you same thing, by the way. You can check it, but why? You have the Spark UI. Check there, na?
Okay.
Why you want to see here?
Okay. Okay, no issues. Then my question is regarding shuffling. So same. Now if we are doing any filtering, it's a narrow transformation, no shuffling. Okay.
Right.
And specifically if we are doing on the partition columns, then it would be more better, right? Now if we are not filtering on the partition columns, we are filtering on a column which is not partition.
We have not partitioned any column. Did I talk about partitions? Partitioned column? We have not partitioned on any column. It is just
but
random partition.
if in the data there are some partition columns.
No, nothing like that. So when we created the partitions, it is all random Spark created. It is not that Goa is in one partition or UP is in one partition. Nothing like that. It is
So
just
I got your
random.
point. I got your point that in our data there is no partition. It is randomly created by Spark. But
Right.
generally in production environments, in our data, we always have partition data, right? Either it will be partitioned on some key or it will be partitioned on some cop date or something, right? So now when we bring that partition into picture, I want to understand how it will behave. Because generally what I see, if we are using non-partition columns in filters, so I just want to understand how it will behave. How those partitions.
We will do that. We will do that.
Okay.
So when we learn partition by in the right API, that time we will see all of this, right? So don't worry. We'll see that.
Okay.
We will create partition data. We'll read it and see how it behaves. Right? Don't get confused now.
Okay.
Yeah. For now, this you understand. Other people also who are listening is just ignore it. Whatever question was there, right? We will see later. Otherwise you will get confused. You just understand this, what I have taught today.
Okay. And then one more last question, Ankit. So regarding shuffling only. So this Spark internally it already try to optimize the shuffling, right? It does the hash aggregate first, I mean local aggregation, and then it does the shuffling, right? So now I want to understand, it depends on executors also. So what my understanding is, whatever is the number of executors, how, so we need to decide that if we want to control the number of partition, then we need to control or decide on the number of executors, right? It directly depends on the executors. Number of executors equals to number of partitions, something like that?
No, number of cores equal to, no, nothing like that. So number of cores equal to number of parallel partitions, basically. How many partitions will be running parallelly will be number of cores, right? Number of partition will depend on size of your file, right?
Okay.
Number of partition. So there are two things. One is initial number of partition, right? Initial number of partitions we discussed, right? It depends on the size of the file.
Yeah.
Right? But after shuffling, by default, it will create 200 partitions.
Yeah.
Right? Now I can change this property to, let's say, 100 partitions. Right? Then it will create 100. Now you will say how I will decide. Should it be 200? Should it be 100? Or should it be 50? Right? Right? By default, it is, if you see this
but
one here.
Ankit, number of cores also depends on executors, right?
So see, so you have, let's say, not number of executors. Cores are independent. So let's say you have 10 machines.
Yeah.
Let's say you have 10 worker machines and each has 4 cores.
Yeah.
So total 40 cores you have.
Yes.
Now within each one machine, you can create 2 executors of 2 cores or 1 executor of 4 cores. But number of cores will not change. Right? Within each machine, you can have 1 executor. We have not discussed this, but since you have asked, I'm just telling 1 executor of 4 cores. We can do that.
Yes.
Machine number 2 also have this.
When you say, Ankit, one executor has 4 cores, it means one executor can run 4 tasks in parallel.
Right, exactly. Right. So each machine will have 1 executor, so total 40 cores. Another configuration can be you can have in each machine 2 executors, each of 2 cores.
Okay.
But ultimately, number of cores are not going to change.
Yeah, that I understood. So
Yes.
my understanding is that at the end of the day, executor is the one which is performing the task.
Yes, exactly.
So
Yeah.
core is something which is the resource available at the executor.
Exactly. So if there are 2 cores available, it will run 2 tasks in parallel, then next 2 tasks, then next 2 tasks, and like that.
Basically, you're saying that partition gets decided not independently on executor. It gets decided first that how many resources altogether are available. That's how the partitions are decided. Then
No, I never said. See, again, I'm telling you again. Initial number of partitions are depend on size of the file.
Size of the
1
file.
GB file, there are 9 partitions.
Yeah. But
Right?
then the Spark optimizes,
Listen
right?
to me. No, it is creating 9 only. What? There is no optimization here. They have 9 only partitions. If you are reading 1 GB file, there will be 9 partitions initially. After shuffle, there will be 200. Apart from that, I have not told anything to you today. That it depends on executor.
Even if we have 40 cores and it's 1 GB file, it will only be 9 partitions.
It will be 9 partitions. No, if you have 40 cores, see that formula I told you here.
Yeah.
Typically, you will not, with Spark, you will not process 10 GB, 20 GB files, right? So most of the times, max will be this. You will be terabytes of files you will be executing, right?
Yeah.
This is a rare case where I'm reading a small file, 300 MB. So that's why it is 6 or 4, right?
That is what. Okay. So it is dependent both on the file size and the number of cores.
Initial number of partition, but after shuffle, it will create 200.
Yeah, after shuffle transformation, it can again change, but initially it depends on as per formula.
As per this formula.
Number of cores and file size.
File size divided by 128, whatever is bigger, that many number of partitions.
Okay. Okay, got it. Thanks.
Yeah.
Yeah, hi Ankit.
Yeah.
Yeah. So I have two questions. So one is, every executor will have cores, right? For example, we have three cores, okay? So it is allocating, the jobs are allocated like 1, 2, 3, okay? In one executor, if some job is finished, it will wait till the next 2, 3 jobs will have to finish, and then it will take, okay.
No. As soon as one core is done, one task is done, next task will be assigned.
Okay,
It
okay.
will
And
not wait for other.
Okay. Thank you. And I have one more question. You have mentioned about this. It will return in disk, right? Again, I think we are going back to that map reduce thing, right? That writing a disk it will take time, and reading from the disk again it will take time, right?
Yeah,
I mean,
but there is a
how the disk?
difference. Yeah,
Okay.
here we are minimizing the disk write, right? So
Okay.
Spark. So in map reduce, what happens for every map reduce, it will write, read, write, read, write, read, write, right? Here, only in case of white transformation, it is writing, not every time.
Okay.
You can have
Okay.
hundreds of transformations, but only when you do white transformation that time. In that also, it is trying to optimize it. It is doing local aggregation first, right?
Okay.
So
Okay.
Spark
And
is doing a lot of optimization to avoid disk write.
Okay. And how this memory will be allocated for each executor? Do we already mention this in compose file, or how
Yeah,
the memory will be
so
there?
we have mentioned 2 GB in compose
Okay.
file, you can see, but by default it gives 1 GB to each executor. We can change
Okay.
it. And we
Okay.
have a separate session on memory management. So let's not discuss now.
Okay.
Okay.
Okay. After the processing, the space will be cleared, right?
Yeah.
Okay.
So after processing, so until and unless you don't stop this Spark session, right? This session has occupied all your resources. So currently nothing is running, right?
Okay.
But if you go to the master, it will say used. See, it has occupied everything. So moment you say spark.stop, then it will be released.
Okay. How about the disk memory?
This memory will be released. Once the processing is done, it will be gone.
Okay. It will create a space and it will delete that space again.
Yeah.
Okay.
It is
Okay.
intermediately temporary. Yeah.
Okay, and one last question, sorry. Spark with SQL, right? That select is an action or it's an call
It's a transformation. So you can say
transformation?
select
Okay,
spark.select. It will not do anything, right?
okay.
You have to just then say show or write or collect, then it will do.
Okay, okay,
So
okay. Thank you.
spark.sql. Yeah.
Sure. Thank you.
Okay, next.
Hi, Ankit.
Yes.
I wanted to know that when you said about when you explained narrow transformations and wide transformations, can I assume that every row level operation is a narrow transformation and every aggregation is a wide transformation?
A join will also be a wide. Now, join is there is no aggregation in join, right? But when you are doing join, you want to make sure that same key should go to same partition. Otherwise, join will be wrong, right?
Okay, yeah.
Right. Again, for distinct, right? If you want distinct values, to find distinct values, same value should go to same partition. Again, this is a wide transformation. Order by, you want to order data, right? So again, it should be same key should go to same place. And again, it is all of these are wide transformations, basically group by, join, order by, distinct.
Okay. And you mentioned that to optimize our query or our job, we use local level aggregation first.
I mean,
And
Spark is doing itself. We are not doing anything.
yeah.
Yeah.
And I mean, if the key in one executor is not present in different in other partitions, so does the shuffling happen? Is a new stage created again?
Yeah,
It's a
it will
very
be created. It will be created.
okay.
It doesn't check data. It knows that there is a group by. So it will just try to keep all the same key in same partition.
Okay, got it. Got
Yeah.
it. Thanks, Ankit.
Yeah. Okay. Next.
Yeah. Hi, Ankit.
Yeah, David.
So, okay, let's say we have 10 Y transformation. So, it will create 11 stages.
Right.
And after that, we are doing any action. So, it will create one job. Is that right?
No. So we have the job first. This is the hierarchy. When job will be created? When you call an action, right?
Right.
Now within job, there will be stages. How many? Number of Y transformation plus 1.
Okay.
Right? Action is not creating any stage. Action is creating a job, and within job, all those things are happening. Right?
No. Okay. So, no, I didn't get this.
Okay. Next.
Hey, hi, Ankit.
Yes, Soumya.
Yeah, Ankit, I have a couple of questions. Like, when we do multiple partitions on a file, so is there a possibility that one partition can fail?
Yeah, it can fail. Then Spark will just reevaluate that particular partition.
From DAG, I think.
Yeah, right.
Okay. The next question will be, we have shuffling, right? So after shuffling, we have 200 partitions from Spark Chain. It's a default one, right?
Right.
So each partition will be of 128 for MB size.
No. There's no size predefined, right? So in each partition, right? If you see each partition is so small here, isn't it?
Yeah.
So it is not necessary. It is, if I go here, yeah. So it is writing just 22 1.5 KB, 1.5 KB of data, right? So this is a very small partitions. So there is no predefined limit. What should be the size? It might be possible one key has lot of values. So it will be a big size partition, right?
Yeah.
Same key should go to same partition. So let's say one key has more number of records. So it will be bigger partition. Another key has a small number of records. Then it will be smaller partition.
Okay. So
You
that
see? No, small. If you see.
okay. So
Then
before
1.1
shuffling,
Yeah.
shuffling, whatever partitions we are talking about, they are of default size 128 MB, right? Means maximum 128 MB size
Maximum
can be.
100. Yeah, that is initial number of partitions.
Oh, okay.
After shuffling, it depends on data.
Mhm. Okay.
See, they
And
are so small, 924 bytes,
yeah.
736, because it is aggregated data.
Okay. So like all these size, like whatever size we are going to get, those size will be resolved somewhere. Means when we talk about disk space, that is something like some ADL space or something.
No, so each executor will have the disk also, right?
Yeah.
So it will write it to the disk, and then next stage will read from that disk.
Okay.
So there are two executors, right? So let me go to the Spark architecture. Yeah. So this is an executor and this is another executor, right?
Mm.
So it will do local aggregation, let's say 4 cores, and it will write it here in
Okay.
its disk, right? Similarly, this will write in the disk, right? And then it
Okay.
will shuffle. Next time, this all data is going to this executor, and this, I mean, not all data based on key, right? Same key will go to here, and same similar keys should go to here, right? So this is how it is. Now, when we do show, right, I was just telling that it doesn't show the full plan. Why? When you do show, right, let's say there are 4 partitions here, there are total 8 partitions, right? Now, when you do show, it has to show only 20 records. Then what it will do, it will say, okay, why to take all the partitions? That's from executor 1. It will pick one partition, bring the data to driver and show me, right? So I was not able to see the full plan, what is happening. Right, that's why I have to write a write job so that it process all the partitions and I can see that on UI. And in actual, also this will happen. You will be writing full data somewhere. Show is just for developing and seeing your transformations and all.
Yeah. Okay. Okay. Thank you.
Yeah.
Yeah, hi, Ankit.
Yeah.
So, as you said, when we are processing a file, the default partition size is 128 MB. So, in which scenarios we can increase the partition size?
You should not increase it. It is not recommended. It should be 128 MB.
Okay. So, when we are processing a bigger file also, it should be
Yeah.
the same.
Yeah, it will be just more number of cycles will be there, right? Because we can have only, let's say, 4 cores, right? So 4 partitions will run parallelly, then next 4, then next 4, then next 4, right?
Okay.
But you
So-
should keep it as 128 MB. This is recommended by Spark.
Okay. So, the next question is when we do the shuffle, we see 200 partitions.
Right.
And there are some other partitions which are empty. So,
Right.
can we limit those number of partitions?
Yeah. So one thing is you can change this property. So this is 200 by default, right?
Okay.
You can make it 50 or 100 or whatever you want. But
Okay, see, yeah,
but you
since-
don't know how many you want exactly, right?
Yeah,
So
here
we will have
yeah,
we will
here
have
we
something
know-
else which will handle this later. We will learn.
Yeah, since here we know the number of states is 22, so here we can limit the number of shuffle partitions to
Right.
somewhere 30.
Right.
Yeah, thank you.
Now tomorrow, let's say there is one more state is coming, then it may be 23, right?
Yeah.
Or it can be less. It may merge two states data and put it into one partition, right? But maximum will be 22 or 23.
Okay, thank you.
Yeah. Next.
Hi, Ankit, Dipanshu this side.
Yeah, Dipanshu.
I just wanted to understand like why is the completion timeline is different when we have like same configuration of executors
Mm-hmm.
and same level of data being processed by all the executors.
Mm-hmm.
So like you mentioned, like there are tasks T1, T2, T3, right, running in parallel. So why is the completion timeline different for each of the tasks completed for within a core?
Okay. So there are a lot of other things related to memory management, right? So when we learn memory management, we will see that
Okay.
it also needs some memory to execute it, right?
Mm-hmm.
There is some garbage collection time, right?
Mm-hmm.
You see somewhere it is less, some places it is more. So once we understand memory management, then you will
Mm-hmm.
understand why some are less, some are more, right? But there won't be much difference,
Mm-hmm.
right? If the number of records are same, right, there won't be much difference as such, but it is a small data, right? So you are seeing 1 second, 2 second, but if it is a huge data and the distribution is same number of records, then you will see maybe 60 seconds, 59 seconds, 61 seconds like that, right? Here you are thinking that it is double, right?
Yeah.
So let's learn about memory management, then it will be more clear.
Sure. Thanks.
Hi, Ankit.
Yeah.
So this local shuffle is for specific transformation. I didn't get that local transformation actually.
Local
Can you explain?
aggregation, not shuffle. Right?
Okay, local aggregation. Okay. Okay, it's not a local shuffle, it's an aggregation you
Yeah,
talked.
local aggregation, right? So what I'm saying, right? Let's say you have one more record, let's say 10, Goa, 100, right? So you have this initial data, right? And you want to make sure that all Goa should go to one partition in the next stage, right?
Okay.
To get the right result. You understand this or not?
Yes, yes, yes.
So instead of sending 3 records of Goa, right, to the next stage, what you will do, you will aggregate it first here itself in partition 1. That Goa has 3 records in this partition.
Okay.
And then you will send only 1 data point instead of 3 data points to the next stage.
Okay, okay. This happens everything from the Spark internal
Yeah,
itself.
we don't have to do anything.
Okay, okay. So I was thinking you spoke about local shuffling or something for
No, I said local aggregation, not shuffling.
Okay, okay. Got it. Thank you.
Yeah. Okay. Great. Next.
Ankit, the thing which you have raised, can you go to the code? You're saying that there is a lazy evaluation, correct?
Mm-hmm.
So what I understand, it is the bottom to top approach. So in that case, until unless action, that means even the compilation is also happening at the end.
Yeah, everything is happening when
So
we
if
call an action.
so, in case if by intentionally,
Mm-hmm.
I'm just thinking here.
Mm-hmm.
In case of just like group by state, if I give some other thing column which is not present in this group by in the data set, it should not throw an error because I'm not calling in action. Does this statement make sense?
This one you are saying like this?
Yes. Yes, I think then it should work.
It is creating a DAG actually, right?
Right.
So while creating the DAG, it sees, okay, state 1 is not there and it is giving you error. But data, it is not processing any data. It is just creating the plan.
Right, but plan means
Plan
plan
means
is
that
just
that DAG is
it is just
getting
that was
created internally. That okay, first I have to read the data, then this group by has to happen. So that plan is getting created, that DAG is getting created.
right, but
Only
in
when
that
you call
plan,
action, that plan will be executed.
right, but in that plan,
Mm-hmm.
they will not understand what is inside the data, right? So state
Ah,
one, state two, they were not. Then why thrown the error?
no, they know the metadata, right? That what columns are there in this.
Okay, so you're saying okay, metadata is also exposed to them.
Yes, yes. We have given,
Okay,
right? Metadata we have given here.
okay, okay. And second thing is that okay, this one. And second thing is that regarding that shuffle partition, that 200 bits. Okay,
Mm-hmm.
so right now we have state of 200, but if we take the state of for the entire 200 countries in our world, so in
Mm-hmm.
that case, my partition size will increase.
It may
So,
increase. It may
so in
increase.
that case, I am
Let's
forced to
say,
change that from 200 to something else.
no. So keep it 200 only, no? Let's say you have 210 countries, right? That's what you are saying.
Mm-hmm.
So let's say you have 210 countries. Your partitions will be 200. Maybe in some partitions you have India as well as Sri Lanka data.
Okay, I got it. Okay, you're saying in a
Yeah.
single shuffle, as as shown us that Goa and UP came into in
Yes.
single partition, multiple keys are residing. Okay,
Yes.
perfect.
Yes. But it is not possible. Sri Lanka is there and it is also there in other partition. That will not happen.
Okay, perfect.
Yeah.
Thank you.
Yeah. Okay, next, quick.
Yeah, hi Ankit, sorry. But that the thing where we were doing byte transformation and after that action, that part is still like still confusing.
What is the confusion?
So like first when we did then byte transformation, it will create 11 stages, and
No,
after
it is
that I'm
not.
doing
It is, you are thinking in a wrong way. You are thinking that
okay.
first stage is getting created,
Huh,
then job is happening, that action is
right.
happening. Not like that, right? Your action creates a job, right? Your action creates a job,
Uh-huh.
right?
Okay.
And then within that job, multiple stages are there, right? Let's say stage 1 and stage 2, right? Now, let's say in this stage 2, you have, let's say, 200 partitions, right? Right?
Okay. Yeah. Yes.
Now, when we are doing write, it doesn't have to create new stage. It will just write this data to disk. That's it. This 200 partition data, it will just write it to the disk. It doesn't have to create a new stage. Stage is only required when you want to shuffle data from one executor to other. Here we don't have to shuffle data to write data. Just if you have 200 partitions, we will write that 200 partition data to disk. Do I need to shuffle data to write it? You tell me. To
No.
write data, should I shuffle it? Not required.
No. Let's just say I have 10 byte transformation. So in that case,
It is 10 or 100. Let's say stage 1,
okay.
stage 2, then stage 3. Keep going on. Doesn't matter how many stages are there.
And is there any relation like in between tasks and stages and jobs?
Yeah, I told you, na. So one action, one job, right? One action,
Mm-hmm. Right.
one job, right? Now, how many tasks will be there? Task depends on number of partitions initially. Right. After shuffle, based on size. After shuffle, there will be 200 partitions. How many stages will be there? Stage will be 1 plus number of
Byte transformation.
This is all you have to just, you don't have to by heart it. If you understand logically, anytime if you are sleeping, someone asks you, you should be able to tell. You don't have to think twice if you understand logically.
Okay. And I have one more question. Let's just say on one data frame, I have done one transformation and one more transformation after that. And after that, one action is performed. That action will be done on first transformation or second one?
Action is overall action, right? It creates a DAG. It is not on particular transformation. So you have some file.
I'll explain this
Transformation
like what I
1.
wanted to ask.
Let me put it. Transform 2. Just give me 1 second. And you are doing an action, right? So when you do an action, this DAG is getting created, right? And it will execute everything. It will read file, do transformation 1, transformation 2, and whatever you're doing, show action. It is not on particular transformation this action is, right? It is on full DAG you are saying action.
Okay, let me just simplify what I want to ask. Let us say I have one df equal to df1 dot persist, let us say. And after that, df dot select.
Sorry, df1 dot
1 dot persist.
Persist, what is persist? I have not discussed persist. Let's say filter.
No, let us say another transformation.
Let's say filter. Yeah.
After that, df dot select.
df dot select. Okay, not df1.
No, df.
Then this will not happen. This will not happen. This will be directly on df.
Then df dot count. So that count will be on without filter data.
Right, exactly. This was never part of DAG because when you say df dot count, it is coming from here, right?
Correct. But
no, sorry, it is df1 or df you are saying?
df equal to df1.
Okay, if you are saying df equal to df1 dot filter, and now you are saying df dot select.
Select, yes.
Then it will be on filter data.
In that on first part, I have not done any action. So that how did that execute it?
No, you are getting confused. See, so you are saying df dot collect, let's say, right? What is df? It will go back. It will say, okay, df1 dot filter.
Okay.
If you say df1 dot collect, right, then there is no filter happening. It is just giving you whatever is df1. Let's say df1 had 100 records, right? And after filter, df has 50 records, right? So if you do df1 dot collect, it will give you 100 records only. If you do df dot collect, it will give you 50 records.
Okay, yeah. Thanks.
Yeah. Because this doesn't make change. So when you do this, it is not making any change to df1.
Right.
Until and unless you assign it to another data frame, there is no change happening in df1. df1 is as it is. It will just show you data after filtering. If you do show, right, it will just show you data that on df1 after filtering, this is the data. But it is not making any change in df1 because this is immutable.
Correct, yeah. Okay.
Right? Yeah.
So that df equal to df1 dot filter, and after that I am doing df1 dot show. So it is not going to give me filter data.
Yeah, it will just show you all 100 records.
Okay, thanks.
Yeah. Okay, last, I need to leave, guys. I'll take this last doubt. Yeah.
Hey, Ankit, Karthik here.
Yeah, Karthik.
Just a couple of queries. First one is related to a continuation question on the previous one where we spoke about 210 countries and 200 partitions after shuffling. So let's say there are 210 countries and then I'm trying to write a row number function. So row number function and on let's say on a particular order by. So basically I'm going to get multiple records which could occupy data more than 200 partitions after shuffling, let's say. Just an example. So in that case, how will the final result look like? Because 200 partitions would have been full. And then will there
What
be
do
any
you mean by full? There is no limit on full, right? In same
Mhm.
partition, let's say this is partition 1,
Okay,
right? I can have India data and I can have Sri Lanka data, both.
correct. So so there is just as spoke about each individual, the initial partition to have maximum size as 128 MB. Is there any particular maximum size for a
No,
shuffled partition?
no,
There's no maximum size.
no.
Okay. Okay, so that was my question. Let's say if there is any maximum limit for the shuffled partition as well, and if unfortunately all 200 partitions are full, the shuffled partitions are full, then how would will there be any cycle where this is stored in the disk, and once again the remaining data would be shuffled and then combined together? So this is an hypothetical question, but I just wanted to understand
Yeah.
the
So
shuffled
basically,
partition
the
logic.
limit is how much memory you have, how much disk you have on that executor, right? So if it is more than that, your data, then it will go out of memory, right? Let's
Okay.
say partition 1, let's say India, right? India has a lot of data and its data is so much that it is not able to sit on one executor.
Right.
Then it will go out of memory, right? And we'll see later how do we handle this case. Don't want to discuss now.
Okay. So on similar lines, so just last question. The basic concept of cores and partitions. So let's say we have two executors and two cores each. So and then so once we start loading the data, like the group by, once you do a group by, you said that each of these while shuffling, the data would be written to a disk. So when you say disk, let's say executor 1 will have partition 1 and 2, and the shuffle logic for partition 1 and 2 would be written to a particular disk, and that disk is on executor 1. Is that correct?
Right.
So similarly, executor 2 also, whatever shuffling will happen will be written on executor 2. So
Right.
how will the data be consolidated between executor 1 and executor 2? Will it be written on the driver's disk?
No, on the executor disk.
So which executor will it choose? Executor 1 and 2, once it has written on individual disks,
So executor 1 will run on its disk, right?
Correct.
Executor 2 will run on its disk, right? Basically, if there are two codes, there will be two files. Two files written, right? Each core will run will write one file, right?
Correct.
Two files. Now this data through network will move, right? So now let's say this is a stage 2. You have P1 here, right? And P2 here, right? After shuffle, I am talking.
Okay.
Right. Now during shuffle, it will check that same key. Let's say Karnataka is here as well as here, right? So internally, it will make sure that Karnataka from all the executors is going to the same partition in next stage.
Okay, and where will that partition be written? As in, is it executor 1 or 2, or will it be anything? It doesn't matter to us because it's
It
internal.
will be executor 1 or 2. We have two executors ultimately.
Right.
It can be anywhere. So some set of partitions will be in executor 2 because there's no relation between this partition and this partition now, right?
Right, right.
So some partitions will be written to executor 1 and some will be executor 2.
Okay, so while we speak about the last set of partitions, the last shuffling, so the previous partitions will still retain the data, right? They will not be released back to the memory. Until we close the Spark session, all partitions, the initial partitions will still be occupied.
Everything is temporary, right? So once it is written to disk, right, they don't have to keep it in memory. So that partitions will be released. Because if those partitions are not released, so they are occupying the core. Right? So those will be released. Once it is written, it will be released. They are of no use once the data is written to disk.
Okay, so parallelly, if we trigger another job, those partitions will be reused by the second job. And the first
No,
job.
so we have second stage is running, right? That needs partitions, right?
Okay, but these are the shuffled partitions, right? These are not the initial partitions.
Right,
So,
but those are also on executors they are running. Na? There's nothing new executors are coming. Ultimately, these are two executors we have.
Okay, so until the first job is completed and all the partitions are released, the second job will be in waiting stage.
Right.
Okay. Yeah, got it. Thanks, Ankit.
Yeah. Okay, next.
That's all. Okay.
Thank you, everyone. So make sure you do this. I will also add some assignment. Assignment in the sense it will be kind of this: read this file, do this, do that, whatever I explained, right? I have not taught you transformations where I can give you some questions that give me state-wise top products and all of that. We will start that tomorrow, right? Today is more about R&D. So I can add some questions, but you can imagine that this is this kind of questions only. Create data, have 2 cores, 3 cores, see number of partition, do shuffle. So you have to just do whatever I have done. Just you have to do by yourself so that you get that confidence. Okay, great. Thank you everyone. Have a good week. Sorry, good Saturday. We will see you tomorrow.
Recording stopped.